This section is 6.6. It deals with volume of prisms. So if you want the volume of this prism, you find the area of the base. So this base here is going to be length times width. And then once you know the area of the base, you can multiply it by the height, and that will give you the volume. So you pretty much just multiply it by all three sides when it's a rectangular prism. When it's a triangular prism, you have to be a little bit more careful. This formula still sort of works. So the length here is 3, and the width there is 2. So the area of the base is 3 times 2, and then the height is 3. So it would be 18 square yards. So length times width times height. Let's do this one. So here, the area of the base is 7/8 times 1/3, and that gives me this area. And then if I want the volume, I just multiply it by the height, which is 2 over 5. And then I can do some simplification here. 2 goes into 8 4 times. So the top is just 7 times 1 times 1. When you multiply fractions, you multiply all the tops together and all the bottoms together. And then 4 times 3 is 12, times 5 is 60 feet squared. Now, 7 over 60 is a really small number. Why did the volume get smaller than the lengths? Well, let's think about a square. If I had a square and one side was 1/2 of an inch and the other side was 1/2 of an inch, what is the area? That would be 1/2 inch times 1/2 inch, and that would be 1/4 inch squared. And it got smaller. Why is that? Well, if this is 1/2 of an inch, then that would be a full inch, and this would be a full inch. And if I draw a square, what do you notice? A square that has a side length of 1/2 inch and 1/2 inch creates an area that is 1/4 of a square inch. So this here is 1 inch by 1 inch. So the area of this square is 1/4 of that. So if you multiply fractions that are smaller than 1, your answer is going to be smaller than the original. They're going to shrink in size. So anytime you multiply something by a fraction that is less than 1, that original something is going to be smaller. All right. So this problem's a little bit harder. All right. A company wants to make wax candles that are shaped like rectangular prisms. Okay. Each candle is 5 centimeters long, 4 centimeters wide, and 11 centimeters tall. If the company is planning on using 5,940 cubic centimeters of wax, how many candles can they make? Well, one candle is going to have a volume of 5 times 4 times 11. So that's 20 times 11. So that's going to be 220 cubic centimeters. So how many candles can they make? Well, they have this much wax, and each candle uses this much wax. So I just need to divide the total amount of wax by the amount of wax in one candle. Cubic centimeters cancel. So 5940 divided by 220 is 27. So I get 27 candles. What if I divided it and I got 35.9? How many candles can they make? What, Gordon? Just 35. Shouldn't we round up to 36? Why not? Why should we round down even though it's 35.9? Well, that last candle is only going to be that tall. Is that a full candle? No. So we can make 35 full candles. Okay. All right. How do we do the volume of a triangular prism? So we sort of can do length times width times height, but the area of the base is not totally length times width because it's a triangle. Now, finding the area of this and then timesing it by its height, is that going to work? No. So what we need to do is set the prism on its triangular side. Like this. And now, if I find the area of the base, then I can multiply that area by the height. So we're going to find the area of the triangle and then multiply that through this direction. So that triangle has a base of 8 and a height of 7. So the area of the triangle is 1/2 base times height. Base times height. So the area is 1/2 times 8 times 7. So 1/2 times 8 is 4. 4 times 7 is 28 centimeters squared. So that is this area. And then I simply multiply that by 9. So I times this by 9 centimeters, and I'll get my answers in centimeters cubed. Okay, let's do another one of those. So the area of the triangle is going to be 1/2 times 5 times 6. So that is 15 meters squared. And then I multiply that by 10. And I get 150 meters cubed. All right. So, distinguishing between surface area and volume. So here we have a shed that's shaped like a rectangular prism, and the shed does have a floor. What is the volume of the shed? So volume is going to be length times width times height, or 12 times 9 times 10, and that's going to be in feet cubed, because it's a volume. How would we find the surface area? Well, I would need the area of this, which is 10 times 12. And then I have two of those, one on the front and one on the back. So I times that by 2. And then I find this area, which is going to be 9 times 10. So plus 9 times 10. And then I have two of those, the right side and the left side. Plus, I find this area, which is 12 times 10. And I have two of those, the top and the bottom. So I times that by 2. So this is the area of the front and the back. This is the area of the left and the right. This is the area of the top and the bottom. And then you just add them all together. And my answer is not going to be in feet cubed. It's going to be in feet squared. And then it asks, if the shed is used for storage, which number describes its capacity? Would it be this one, the volume, or would it be this one, the surface area? That is volume. Okay, if you wanted to paint the inside of the shed yellow, which measure would you use? And the answer is surface area. All right, that's it. Get to work.